Now, before I start going into how lighting works in 3D modeling in Blender, I thought it worth talking about just a summary of how it works a little bit in real life. So in real life, lighting works from some light source, something that is going to make, I'm going to try to have a little icon here I can use real quick, a little light bulb. There we go. And let's give it a light emitting color. Cool. So we have some sort of light source that is emitting lights in all directions as both a particle and a wave, yada, yada, yada. Now, when our eyes, let's see if I get a little eye con, little pun there. Arc shape. This one here. And we'll make that. Whoop. And then we'll add one more little light or thing here. Elongate it, rotate it. I'm spending more time on the artwork in slides than I am on the class. And let's group this together. All right, so our eyes perceive the light as these particles of light enter our iris and excite the nerves in the back of our eyeballs, the ones that detect light and darkness, the rods, and the ones that detect different colors, the cones. I may have that backwards. I am not a eye biologist. In order to see things in the world, so we have some kind of object in the real world, the light that hits the object will bounce and reflect off the object and hit our eye, and that's how we're able to see. Without a light source, we can't see. That is where darkness comes in. Depending on the material properties of the object, the color of the light might get changed, like it might be coming in as near white, which I'm not going to, if I've got a white background here. Actually, let's make a little black background real quick. Let's make this all in a dark void. Okay, so as this light approaches the object's color, in this case, let's give it something. Let's give it a red. As the light bounces here, the object absorbs some of the light, and some of the light gets reflected. Some of the light that gets absorbed then gets re-emitted if it's a fluorescent surface, like if you ever looked at like a kind of fluorescent material, either in like a black light, it can change what that color looks like, or it enters the molecules of the things, and then the light that it gets emitted is usually some wavelength less than what came in on. What that means is that, white light comprises the whole spectrum of light, but the red is only one small band in that whole spectrum. So what we end up getting here is the red light reflecting off instead, and that's why our eye will perceive this as red. Fun story, in the real world, if I, for instance, had this emit as a, I didn't want to make another one. If I had this emit as, say, blue light, and it hit a red object, it would instead reflect as no light. It would basically be deleted. So there's no red in blue light. Like if you look at a color spectrum, the red band does not contain any blue light. So if the blue light hits the red on a red object, now this object is absorbing all other light colors except red. So what our eye would perceive is a black object, even though the object would be physically red. And then keep in mind the color wheel is not real. If you ever looked at a color wheel, we start on one section with red, and then on the other end, it kind of loops back around toward purple, and it blends into the red. That's not actually how any of that works. There is technically no such thing as purple light. It is a mixture of blue light and red light. Because you look at the number line, the color spectrum of visible light. Our eyes can only detect 3 different colors on average: red, green, and blue. Some people are tetrachromats. They can detect yellow distinct from green or red. And then there are some people that have less rods and that they have some level of color blindness. When we see a bit of color that is yellow, for instance, that is on the color spectrum somewhere between green and red. So the way our eyes interpret this is our red receptors fire, seeing that they have some red light, and our green receptors fire, seeing that we have some green light, and then our brain interprets that as yellow. If a person is a tetrachromat, then they'll see the yellow lights more distinct because they have more ability to detect it. But halfway between red and blue on the color spectrum is actually green. But our brain doesn't know how to interpret when I see red and blue, but I don't have green. What could that possibly be? Well, there must be some other color there. So purple, magenta, that whole section of the color wheel doesn't really exist. It's just a figment of our brain's imagination because it's got to work with and interpolate from limited understanding. Now, something else before I go into this any further, I'm going to turn this back into a white light. So this will be the red light. Is something about diffuse. So how much of the light is diffused into the new color, and then how much of the light will still emit as it's just reflected. So diffusion means it's been modified by the material. Then we have reflection, which is not modified by the material. So what we end up having is more like this will still be white if we have a shiny surface. And then we end up getting a whole lot of smaller, less intense scatterings in red. I clicked on the wrong thing. All right. Like so. So if you ever look at an object that is highly reflective, you will see more of the light that has been reflected and less of the light that has been diffused through it. So this is diffuse lighting, and this is called specularity, specular lighting. So it is the reflection of it. And there's a lot more properties in this. Some of the light, depending on the translucency of the material, will pass through it and refract. Like if you've ever seen the Pink Floyd album cover with the prism of, white light goes in and all of the light bends and isn't, pulled apart into its component light sources. That is another thing that can happen when we have translucency and an index of refraction, as well as subsurface scattering, which is the material itself kind of lights up and some of the light gets caught inside at the point of contact, and then will still exit somewhere down, but it'll have been modified more by the object. It gives it almost like a soft glow or fleshy or waxy look. All right, enough about the theory. Let's take a look at how it works in practice. Well, if you want to see how light works in practice, just look around the room that you're in. I'm sure you have some light source, at the very least the computer screen. But in Blender, or rather not specifically Blender, but in computer simulation of light, things don't really work that way. There is, let me start here with this default scene. I'll add back the default cube. And let me just, render this scene. We have, the cube with the one light source that is reflecting light here, diffusing light here, and highlighting this more, and highlighting this a little less. And then the opposite side doesn't get light at all, but there's still a little bit of ambient light being applied here. In fact, if I were to delete this light entirely, snap the cursor back to origin and render it. I can still see the object. I mean, there's a default background color, but the object is still kind of lit up just a little bit because there is an ambient light that is being applied here. I don't know where that option is off the top of my head. I'll have to look that up, or if I can find it somewhere in the renderer settings. It's probably somewhere in here, but I'll go through it at a later time. All right, I've given up. So in 3D, we kind of cheat a little. We take the color of the object that we're rendering, and then we try to balance both additive and subtractive nature of light. What that means is that a light can create darkness by casting a shadow. We can have, or otherwise the shadows that wouldn't necessarily exist. We can cheat by having just ambient light, and everything gets rendered just a little bit based on its color. So like we don't have to necessarily have lighting made perfect for the real world. There are also ways we can handle lighting that make it look a little bit more realistic. So let me add a light here. So in the add menu, you can go right down, there's a light section, and I'm going to add back a point light. Now this light here, and if you go to the light properties, we can render the scene again, and we can see, ooh, why does that not light up? Maybe it doesn't have enough power. Let me undo a few times and see what the original light looked like so I can compare. All right, power is 1,000 watts. When I make a new light, its power is 10 watts. So, okay, there's a power issue here. So let's make this light 1,000. And now when I render it, ooh, it's extra bright. Let me move this light around over here a bit more. You can see now the two lights are adding together. So each of these lights works towards brightening the scene. Now, as I mentioned, the properties of light don't necessarily have to emit a pure light color. Here again is the lie. This section between blue and red does not exist in nature. Technically. I guess it does. It's because we can perceive it. Whatever. But I can make this, say, a green light. And then this is going to add green light to the scene. It is not working with the diffusion property of subtracting light. We're kind of faking it. There are ways we can fake it, but it takes a lot of work to get it to be more of a realistic simulation. Generally, unless you're trying to do something perfectly photorealistic, it generally tends to not be worth it for most applications. Like for instance, if I made this cube, if I go to its materials properties real quick and just set its base color to red. Actually, I'll just RGB. Just make sure it's pure red and no other colors. And now render that. It's pure red because I'm using some like diffuse color more than anything else. In theory, I'm not going to try to doing it now. That'll take time. One thing you will notice as you go through anything in 3D modeling is that every little tweak you want to do, you will spend hours working on tweaking little settings to get this scene look just the way you want it. And it will have only felt like 10 or 15 minutes have passed, and really it is now tomorrow. So I'm going to resist the urge to mess with it now. Just so we know we have the emit color, or the base color seems to have a greater weight in the final color, with at least the default settings here. So I'm going to turn this back to hue, saturation, value, and the saturation back to 0. So we have the default, gray-ish cube, with the green adding a lot of color here. Now, it's probably because I had that light on. Never mind. Deal with that later. These point lights, let me talk about lighting, because again, this is the lighting tutorial. These work by, if you look at the little icon, it kind of hints at it. It emits light in all directions. And it will do that at a power on the scale of wattage, which is quickly becoming an obsolete, yet we're still using it, term to measure the intensity of lights. Back with incandescent bulbs, the wattage would be a direct correlation to how bright a light bulb would be, and they were sold as wattage, not as lumens, which would be the actual measurement for how bright something is. And now that we have all these LED-based lights being released that are being sold as, this is a 60-watt LED, but it only uses a half a watt, because it's the equivalent to a 60-watt incandescent bulb in brightness, but you're not using the same kind of wattage. So wattage, silly. But what have you. So the power is how bright the light's going to be. The diffuse, the specular, and the volume. So this is how much light we're going to be factoring into the diffusion factor of our object, how much specular, how much volume. So we can control this on a per light basis. In the real world, there's pretty much just light of different wavelengths and how much of it. We're faking it here. We're not actually doing the physics involved. We're not doing the real-time ray tracing on a per photon level, which we would need to have perfect real-world simulation, which would be absurd. We don't need to do that. We can fake it. So these work in all directions. So no matter where I put this, no matter how many different objects in the scene, let me actually add a couple more objects in the scene. Shift D duplicates the object. And you can see close, far, off to the side, the different ways the lighting. Let me see what my camera sees. Just get it all in frame. Maybe get one more there. And one more out there. There we are. Let's see what that looks like. All right, now we can see how the different lights, like the point lights reflect the green. Let me give another contrast color so we can see what the other light is providing here. So contrast of green would be purple. One of the lights. So you can see the stuff that's closer to and facing the object. So the power will help by distance, and then the faces that are in the direction of the light will absorb more of that light color. You can see how that different affects here. Let's even add a plane here to this whole scene. Oh no, let me Alt-G, put that back to origin and scale it out, and grab it and move it down to the plane. So F12. There we are. I even have some things to collect shadows from. You can see the shadow provided by the green is being more lit up by the pink light. And the shadow provided by the pink light is picking up more of the green light, as opposed to the areas that are getting a little bit of both based on distance. Now, let's talk about some of the other light types we have here. I'm going to add a light sun. The sunlight is an omni-parallel light. The idea is that if you look at the real world, our sun, which is a giant flaming nuclear ball at the center of our solar system, is providing light that is from a surface that's 1,000,000 times the size of the Earth's surface. For all intents and purposes, the sun may as well be, and it's so far away that all the light that is being sent from the sun you may think of it as radiating out, but as far as we're concerned, this far away, we're 8 light minutes away from the sun, which means it takes 8 minutes for the light to get to us at the speed of light. All the light may as well be parallel. So these point lights radiate outward. The sunlight, it's going to be all in one direction. And let me rotate that like this, like so. And now when I render the scene, let me turn off let me delete the other lights. No, not the camera. The lights, delete those. So you can see these lines are functionally parallel. Meanwhile, if I had if I add back a point light, that point light can do nothing because it needs to be more powerful. And let's make this light have blue, red, blue, blue, F12. you can see, and then let me turn the sun off for a second. Now the sun should be off. See how the lines fan out. This is like a projection from all of the light emanating from the point light. But the sun, going back to a strength of one whole sun, all the sun's shadows and lighting is done in parallel. So sometimes your scene will call for lighting from such an impossible distance that you would end up making them functionally parallel. But if they're closer, you're going to want to have like a point light. Now, as I mentioned, I'm from the theater, and sometimes we want to stage a scene and have focus tightly placed based on a spot light. We have those lights as well. So I'm going to add light, spot. Now this provides a cone of influence. Once again, I'm going to set the power up to 1,000. I'm going to set the color to, let's see if I have blue. Let's go with yellow. I'm going to rotate that way. That way. No, I'm going to put the spotlight. Where's the camera? Put it up near here, the camera. And rotate down and rotate that way. Now we're focused basically where, no, that's not where the light is. Deep, deep. Let's see what that looks like. Let's turn off the other lights. So collect the sun, turn that off. Select the blue light. All right, it's easier to just type out 0. F12. All right, so now let me pull it up a little bit. So actually rotate XX. Oh, it's all kinds. Let me Alt R. Rotate it that way. Rotate it that way. Remember, objects keep their relative original orientations, so I can rotate along its original x-axis, or its local x-axis, or rotate around its original y-axis, or rotate around its original z-axis, which doesn't make any difference. So now it's 1,000, and it's from where I'm looking, and that's what we see here. I'm going to make this even more intense, because I moved it a bit further away. Yeah, actually, let's take a look at what the scene looks like. You'll notice that there is the circle of influence here. So this spotlight is like as if it were being shown from out of a light. Now, all light sources in the real world are omnidirectional. They will emit it in all directions. But then when we put them in a lighting fixture with mirrors and lenses and shutters, we can focus that light into a specific direction. This allows us to have like a conal shape. So things that are closer to the light will have a smaller circle projected of light projected on them. Things that are further away will be further out. We can also adjust how sharp the edge is. So right now this is kind of diffusing a little bit around at the edge. And we can control what that looks like. So our spot shape, we can increase the size. You can actually, let's tighten it down. So now we have a tighter spot. Oh, neat. Let me once again rotate YY. Let's see if I can get that right. And rotate Z. There we are. There's the nice spot projector. You can even see the shadows being cast by this light, by these areas not being highlighted. Further away it fades, closer it's brighter, and then the edge around the spotlight is soft. Let's see if we can tighten that up. Our blend, let's go wider blend. Now you can see the fall off happens more exaggeratedly. Or no blend, and we have a very, very rigid, tight spot, which, by the way, if you're working with real spotlights in the real world, are ways we can actually control that with a shutter. We can tighten that up, tighten the focus. Sometimes you can even project shapes, cutouts with something that's called a gobo. And then, of course, changing the color of the light with what it would call a gel. So in this case, I would be functionally having like a yellow gel as opposed to no lighting change at all, or no color change at all. Well, oh, shadow casting apparently is optional. So now we don't cast a shadow with a spotlight. We're just going to call attention to it. By the way, not all renderers work with shadows the same way. And casting shadows is extra work. Because not only do I have to calculate everything that the camera sees when I'm rendering a scene, so I can occlude things so that I have a depth, so I know what's behind things. When I have shadows, I basically have to do the same thing to figure out what every pixel is able to see the light or not. So we actually render this, whenever we cast a shadow, we have a light that does shadowing, we're doubling the render time. Not doubling, because there's still additional After Effects that would happen for the actual render, but it is still functionally doing very much like a scene render per light that casts a shadow. So if you're finding that your renders are taking an absurd amount of time, check to see how many of your lights cast shadows, and do all of them need to? Maybe just a few will be enough. I've looked at some recent games that are even on the PlayStation 5, and in each room or volumetric chunk, most games generally don't have more than one or at most two lights that will cast a shadow for whatever the actors are that move around. The rest of the shadows are oftentimes just baked into the scene, pre-calculated. All right, there's a final light, which I believe is a area light, which, let me turn this light back off. And now let's play with the area light that I just added. The area light is directional, just like with the sunlight, the spotlight, but it doesn't fan out if I remember correctly. So let's see what this looks like together. Barely said it all. Oh, forgot. We have to add some power to that. Let's make it 2000. Ooh, wow, that's bright. So it is like the sun in that the lines appear to be parallel, but I believe also then like the spotlight, we can change its shape and dimensions. So let's take a look at our light properties here. So our clip bias, F12, our clip bias all the way up. Interesting, I don't know what that meant. Oh, clip start, oops. Clip bias. Apparently it only goes up to 5. And with it off, or practically off, I'm not sure if you can tell the difference there. Contact shadows. Oh, it's weird. Yeah, I do believe it's parallel. If I remember correctly, I can also adjust the shape. There's square shape. So how large it is. Let me try a square. Shrink it down a bit. I'm not seeing a difference there. As far as I know, it's no different from the light. I'll have to look up the properties there and I'll get back to you in the chat. But that's not the only way we can provide light. Objects themselves can end up producing light. So I'm going to go into another video, probably immediately following this one, in object materials. But for now, since we're talking about light, we can scroll down to emission. And we can have our object here emit light. So I'm going to set this to a color. Let's see, saturation all the way up, brightness all the way up. Let's have this emit a green light. And the emission strength is currently set to 1. Oh no, they all have the same material. All right, they all have the same material. Let me delete all of those and then add a couple of empty cubes. All right, that one's apparently still there. That's the same material. But this is now emitting light, regardless of whatever light is hitting. Well, not regardless, but in addition to, it will add its own light to the calculations as it goes. And that's emission strength 1. We can have it even be brighter. but it's not actually casting light on anything else. It's just as if it's lit up from the inside. Kind of like how a Minecraft activates its lighting blocks. Like they will emit light, so they'll be brighter, but then there's also the calculation for casting light as a source. And there's that stuff I'm going to go through in a future video. All right, so those are the basics on lighting. Sun, if you have an outdoor scene, a sun is probably a good place to add. In fact, you can also simulate moonlight the same way if you just, dumb down the strength of the sun and maybe color shift it a little bit. And you can get a moonlight-like effect. I'm probably going to provide some other links to on more discussions on lighting in general, lighting a scene, lighting for theater, lighting for whatever your needs may be. I hope this is a good starting point to learning about lighting. This is something that I want you to consider, and it will take time when you're working on your projects. So for the midterm project, lighting is one of the things that is going to be factored into your grade. So how much detail did you attend to the lighting? How close to the original scene that you're trying to reproduce did you capture the lighting? So look at the scene, look at the light sources, count them out, list them out, identify how you're going to model them and how you're going to make that work for your scene. And if you try to match it as close as you can to your source material, to just get some practice on trying to create a specific effect that we can all appreciate. All right, that's it for this video. Thanks for watching.